Hi, today's video is about electronics again, and this video is also recorded over more than one day because it is kind of concluding the topic of the version 3 controller. If you have watched the video of designing and ordering PCBs, now 10 days later I got the package and the PCBs arrived at my door. And let's look inside the box. And you can remember we ordered 3 different kind of PCBs. One is this small adapter, which is basically an adapter from a Nano to the Mega, which we are using on my controller. And then we have the Watchdog PCBs. We have 8 of these small boards on one PCB. And then finally the version 3 controller. You have all already seen people soldering this kind of stuff, so I will not show you this because it's boring, of course. I will finish this one first and then the version 3 controller, and last but not least, because I never soldered SMD before, that will be the most fun. We'll try to make a watchdog. Okay, number 1 is already finished. So this is the adapter from Nano to Mega Pro board. Here the Nano comes in on top, and then this can be used on my controller on any of the versions and plugged in here. So now this combination can be used if you just need some simple features, only 1 or 2 features of the controller board, and can just use a simple and cheap microcontroller for this. Okay, and the controller board is finished. So last PCB we have to do is now the watchdog. So this is SMD, and first time that I ever will solder with a soldering iron SMD components. I watched several YouTube videos, and so I will do it the way that I use the plugs, put it on one bed, then pull the component in place, and then just use the iron with the flathead, which will have some solder on it, and then just tap on the item and flow the solder towards the component. So let's see how it will work. I have this holder here, and I will try to finish this one here. For the resistors, I ordered size 0603, but they are really tiny already. I saw they are bigger in real life. The capacitors, I ordered the size 0805, and that looks quite okay. Okay, let's try this one and then see when it's finished how it looks like. If I knew that 0603 is this small, I would actually have taken also 0805 for the resistors. But I'm finished with the resistors and capacitors, LED and the other diode. I have changed my tip to the normal one. The other one did not work so well. I have already learned something from this, and what I've learned is that even this 0603 spec size is too small for. So if I ever do this again, the smallest size will be 0805 for DIY. I think that would be much easier. Okay, I have now 2 ICs left. One is the double MOSFET here, and the other one the timer chip. I will solder this one now, and then we are already finished with SMD. That is it. The watchdog is finished. And here we have it now. The watchdog is in action. We have a nice bright green LED on it. So as long as the LED is shining, the watchdog is keeping the microcontroller alive. On our serial monitor, and here we have it again. You can say that I will not tell you when something is not working. I have built up several of these watchdog boards and they did not work. I was testing around. I built them in several steps, so to just test out the circuits, the different circuits which are on that board, and it turned out that it is the timer circuit which does not work like it did before on the SMD version only. So the timer chip SMD version seems to be different than the through hole, and it just does not work. So what I had to do again, I had to build me a prototype of this one again with the through hole components, and this one is working very nicely. You see, it is sending the data, no resets, and that capacitor is having a 24-25 seconds timer, so it will now disable then it will now then enable the reset. Oh, this sucks again. You see, now it's activated. It works so nice on the regular components, but when it comes to SMD, it just doesn't work. It's switched on again, and here we have the reset. Okay, so I have to use now this prototype watchdog, because this is the main feature of the new version 3 board. So I have to do this and just use it this way. Maybe one day I will then again change it and make a new board for it. But that time just with proven through hole components then. This is now how the board looks like. So the new, unfortunately, prototype watchdog. Then we have the new Ethernet connection, and these are the temperature sensors. I will put them into the battery compartment. But here in my place we always have nice hot temperatures. So these are the new 3 temperature sensor connections. Okay, let's go to the Powerwall and we will swap the version 2 board against the version 3 board. It's 2 o'clock in the afternoon, so the Powerwall is just getting full. My cutout point is 94% by voltage state of charge. The colorimeter is already showing 100%. So we will stop any moment, and that's a good time to change the controller board. So we did not lose any power. And just for information, the last month was the best ever we had here on the Powerwall. We have captured 375 kilowatt hours, which would have been exported else to the grid. So very nice indeed. And let's wait a few more minutes and then we're gonna swap the board. It's very easy because it's just the board. All the other connectors, relays is separated just to plug in. And what I wanted to show you, so I can look here, you see the number on top, 248,000. This times 10 is the seconds since when the controller was restarted last time. So that's almost 4 weeks the last time that I have uploaded the new software version. So it never resetted in the meantime. And this is what I want to see, of course, also when we then have the external watchdog, when the machine is also connected to the internet. I don't want to see any more resets here. It's 94%, so any moment that the controller will call it a day. Okay, the new controller is inside. Finally, I was really lucky to see the prototype watchdog. It just barely fit inside there with the relays, so it was really an exact fit. But that was not planned like that, of course. Okay, let's close the box, and I have already installed the new software for the version 3 controller and then start it up. Let's try it out. Okay, we have to set the date again. The clock is reset. And this was not a watchdog. It took too long to come into the normal sequence, so I have to make a watchdog reset somewhere at the initial startup routine. Let's do that. And it's again the next day. I have worked on the software and eliminated those last bugs, so it should work. We will now then flash the software on the microcontroller, and in the meantime I want to show you what I did with the temperature sensors. I have them here now on the batteries. You can see it here. I used some plaster for the heatsink plaster, it's called. So this is basically glued onto the shell of the batteries. So three sensors there. Okay, let's plug in our connection to the computer laptop and flash the latest software. It will take a little bit. Okay, let's start it up. Connecting Wi-Fi. Connecting Blink. Okay, connection is established. SD card will start logging and the mode is starting. Okay, now I can show you the sensor data. On the second page we have now two subpages, one subpage, and there you see now, here you can see now the sensors. We have the highest at the moment, 35 degrees and 34 the other ones. So this is now directly measured at the cell there with our new sensors. Okay, the only thing we can do now is wait for more than 24 hours so that we can see if the controller will reset or not. So next update tomorrow afternoon. It is morning and we are doing well. You can see here the number 5,000 already. One day is 8,400, but we are more than halfway through our mission. And yeah, I already saw yesterday once at the controller that it was hanging for a while, for almost 20 seconds, and it then continued, so it was kind of stuck somewhere in the communications loop and it did not reset. So I'm very confident that this is working now. Here I have now another new number that is from my temperature probes, and what I'm showing there is the highest of the three. So the first number is the sensor number 1. It does show 29 degrees now. Yeah, so afternoon, when we get 5 digits there on the millis timer, then I will call it a success. Finally, we got it. It's the 5th day of recording for this video, and we have officially passed the 24 hours mark without a single reset on the new controller with the external watchdog. So the problem is solved. We have extra features. Everything is working. The only thing, unfortunate thing, was that the watchdog PCBs did not turn out to be functional. I have experimented a few days now, 2 days, and I found out is that the SMD components of the NE555 timer chip, they are working a little bit different than this one, the big ones. The big ones are much more tolerant to changes in the setup here. So after I've changed the resistors here and capacitors to the same values as on the reference system from Texas Instruments, actually this circuit works. So I had a fully functional circuit, but I could not scale it up to a long enough timer interval. I had a very nice flip-flop timing of about 2 seconds, but that was it. I need, of course, much longer times. We have 25 seconds now on the prototype, and that is perfect. I think everything shorter would even be too short. Okay, so I already also ordered the new PCBs. The new PCB for the watchdog. It will be just a little bit bigger, but that can already be just built up with the bigger through-hole components. Okay, so almost everything worked out to be good, but the more important thing is that the controller is now working as expected. You can now already find the software also for the version 3 controller on my GitHub page with the new features, and there's now 2 software versions, version 1 and 2, and then the version 3, because in the version 3 there have been also some changes in the pin configuration, so that's a little bit different. So that's why it's a completely different software there. Okay, so maybe somebody of you has some experience also with this kind of SMD versus through-hole components, and can leave a comment on the down why this is behaving so differently. And yeah, I hope you still found it interesting Well, thank you for watching this video, and please like, subscribe, and I see you next time.